Let's talk about formatted output with the printf statement. So we're in Hello World. Just about every Hello World in the planet starts off with printing Hello World, right? So we're in C, obviously, and the printf function is used to print output it's one of several functions available that will print output to the console. So if we compile this, just a review, the way that we compile this program is we're in the same directory. So if we do an ls, we'll see that we have our hello world C, and we've already run this from an earlier video. So there's a hello underscore world.o for the output file. So we call the GCC compiler with GCC, and then specify the output with the dash O, not a 0, but a dash O, and then hello underscore world. And again, this underscore, this hello underscore world, it could be anything, right? But because the name of the C file is hello underscore world C, I'm using hello underscore world dot O for output, right? And then the name of the file to compile, hello underscore world dot C. So then you hit return, and then if all goes well, you'll see no errors. And then you should be able to do a ls and see the output, right? Which we've done earlier. Clear the screen, and then to run it, build / hello world.o. Okay. Hit return, and we see hello world. Okay, now let's print that using a little bit different technique, right? So what I'm going to do now is I'm going to add a printf conversion, okay? And let me show you. So you just do double quotes again, and then a comma, and then you type %s for %string, okay? S indicates a string format specifier or printf conversion. I like to call them format specifiers, okay? But I think the text calls them print conversions. So this S right here, or the %s, says there's going to be an argument, and you will format it as a string, and then comma, and then the first string after that comma is the argument that will be passed, that this S represents, right? So this printf statement will say, oh, okay, there's a format or a printf conversion, S, and here's the argument, which is of type string, and I'll put a space after that comma. Make sure that you save your code, and then return to your terminal and compile it and run it. And it looks exactly the same, right? Now, one more tweak on this string. Let's say that we want to do, we could do it a different way. We could say %s. Now we have two of these printf conversion specifiers here, right? These format specifiers in this first, set of double quotes, and then a comma, and then I'm going to put a double quote there, and then a comma, and then a double quote here, and I'm going to save this. Now, okay, so everything looks fine. So now I have two string arguments, and I have two printf conversion. Okay, so %string. Now when I compile this and run it, we get exactly the same looking output, except we're doing it a completely different way. So there were three different ways of printing hello world. So the first one, let me just copy this and go back, right, just to show you. I'm going to just copy printf here, and then another one. So the first one was just this. hello world. Okay, in one string. The second one took one printf conversion and one string argument, hello world. The second one, or the third one, takes two printf conversions and then two arguments. So the first argument belongs to the first S. The second string argument, it then is associated with this second S here, okay? Or printf, or the percent %s specifiers. Now, when I run this, all these are going to print on the same line. So what I need to do is come up here and add, if I want them on separate lines, I need to add /n, and then /n, and then /n. And once again, /n is the escape sequence for a new line. So make sure I've saved, okay? Return to the console. I'm going to clear the screen this time. Hit my up arrow key a few times, recompile, and run that. And we get hello world, hello world, hello world. Now this material for this particular video and this lecture comes from the C Programming Language 2nd edition by Brian Kernighan and Dennis Ritchie. And this is the main reference I use for this boot camp. It's still relevant. It's concise. It touches all the high points. If you read this book and you followed the exercises and attempted or typed in all the examples and, attempted the exercises, you'd be pretty good with C, right? Of course, the only way that you get super good at C is you got to work on a serious big project, right? That's just how you get good at any language. But specifically, Chapter 7, Section 2 talks about formatted output with the printf statement. I know that's a little small. Let me make it bigger for you. And so there's a table 7.1, and this table, the table lists the printf conversion characters that you can use. Right now I'm using an S for the string, okay? But you can format numbers, integers, floats, pointers, okay, using a variety of different formats that you want to display those numbers in. You can display a number as an octal, as a hexadecimal, okay? So I'm not going to go through every one of them, but I do want to touch on this list up here, this bulleted list, which is very helpful. Now, a lot of folks that I see in their code, they never get past, just printing out a string, right? But you could think of these format specifiers, especially if you are a Python programmer, as like F strings, right? F strings, you can specify a formatting for the variable that you pass into the curly braces, right? I don't assume that everyone watching this has Python experience, but if you do have Python experience, this is very similar. So you can actually modify the behavior of these conversion characters by either with a minus sign, which specifies left adjustment, a number that specifies the minimum field width, okay, a period which separates the field width from the precision. And this has a different effect whether or not you're printing a string or you're printing a number, okay. A number, the precision indicates the maximum number of characters to be printed from a string or the number of digits. So let's just go through these things, right? And then that will be it pretty much for this video. All right, so let me return to the VM. Now, let's go ahead and format a number. I'll format an integer, and I'll use the D, okay? So if we go back real quick, pardon me, to that table, we see that D can be used for decimal numbers, right? Or for integers. And so let's go back to the VM. So printf. So again, this format specifier starts with a %, and then D, and then come outside that second quote, and then let's just use 100. And then don't forget your semicolon, you Python programmers. Save your code, and let's go ahead and I'm going to clear the screen for this. So let's go ahead and compile it. Don't forget to compile each time, and then run it. So now we have 100 printing out after the third hello world line. Now, if we wanted to specify the minimum number of spaces that this number would occupy, we could add a number here. So we could say, let's say 10. Okay, that'd be the minimum number of spaces. Well, okay, so let's just see the effects that this has on the output. Okay, so notice that the number specifying the minimum number of spaces that this number will occupy, you can think of spaces as columns in a terminal, is between the percent and the printf conversion character. So between the percent sign and the D, you put a number. Okay. Now let's go ahead and recompile and rerun the example. And we see that 10 now is all the way over here to the right. Okay. And if we counted as best you can, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that right there is 10. And of course, this, I think this has 12. 10, 11, 12, right? So Hello World has 12 characters. And then this is 10 chars here. So let me just line it up. Let's just say 12. Just to make that line up better. 1, 2. Okay. Save it. Clear the screen. Compile it. Run it. And we see that now this 100 is lined up, right? So now let's say that we wanted to print a decimal. So I'm going to just copy this. Oh, yeah, so we'll do that. I don't know about you, man, but I like doing this stuff. It's fun. Okay, now let's add a negative sign. Save it. This will left justify that next 100. But you know what I need to do? It's not going to work right unless I put a /d. /d. I'm sorry, /n for a new line. Save that. You know, up here I put the /n here, which makes sense, right? I'm glad I did this. And then up here I put /n. I shouldn't have put /n here. I should have put /n here, really. Okay. And I guess I suppose it depends on what you're doing, but then I should have put it on the second argument here. It'll look exactly the same. I just wanted to bring your attention to that. So now I have a /n. I'll put a /n here just to make sure. Well, I'm not going to do that yet. Okay, so now I have a negative sign in front of the 12. And the behavior will be to left justify this number. So let's go ahead and compile and run it. So now we see that the 100 is left justified. Let's go ahead and add a slash or a /n. Ooh, I don't know what I did there. All right. I'm going to put a /n right there. Okay, now let's copy this and print out not a decimal, but a float. We're going to print out a floating point number. And we'll say it's 100.001. Save that. So 12 space, the minimum 12, floating point 100.001. Clear the screen. Hello world. Run it. So, and there's a negative, right? So it's left justified. I'm going to take off that negative and just keep it right justified. So we got to compile it again. All right. So there we go. This is right justified. And notice that the precision is 6 decimal points by default. 100, and we're getting 12 characters of minimum display space. So let's go ahead and change this. I don't know why it's doing that for me here. Let's change the, we see this right here. We have 3 decimal digits. Let's just make that 3, right? 0.3. All right. Actually, I'll just leave it like that. And then what I'll do is I'll copy this so we can see the effects of each change. Hit return, save. So now I want to say minimum of 12 spaces for the entire number and precision of 3 decimal places, or past 3 digits past the decimal place. Save. Let me clear the screen. Compile and run. So there we go. We have 100.01. Now let's change. The precision. I'm going to change this number from 001 on the next one to a higher number, and then we'll see the effects of precision and rounding. Okay. So copy that. So I'm still going to go with percent 12, which is the minimal number of spaces to print this number in. Right justified because there's no negative. 3 for the precision. And I'm going to change the number here to 6 just for demonstration purposes. But I'm going to modify the number precision to 2. So now watch what happens with this 0.006 when we decrease the precision. It's going to round that number up. So save it, clear the screen, compile it, run it. That's your coding loop. Make a change to your code, compile it. So notice that the number was 100.006, and then when it rounded up, it rounded it to 1. Okay. So just note that there's the effects of, rounding when you change the precision of the number. Okay. So I should have just printed this with 3 and then went ahead and change that precision so you could see the effect. Like that. Okay. So save that and run it. And there we go. So there was our number 100.006. That's with a precision of 3. And then with a precision of 2, it rounds it up to 1.01. Okay, so just keep that in mind. Now, if you wanted to print like a column of numbers, right, you would have, printf, and you could have the first, let's say we wanted this, here. I should have just copied that whole statement. Then you would add, you take out this /n, and then you put a /t in here, okay, for a tab. And then you could repeat this precision statement. Like that. And then let's say that we wanted to put an n here, and we'll repeat another number, 200.0.26, let's say 298, right? So we'll see the effects here. So what do you think is going to print on this 298? So we know what's going to happen here. This 100.006 is going to print as 100.001, right? So doing these little examples, you know, it may seem like you're not doing much, right? But when you spend time to explore the capabilities of a particular language feature, then it does become quite enlightening as to, you know, what you can achieve. All right, so here we are right justifying, right? We have two %fs in this format specifier string. So because there's two %fs, right? It expects two arguments, right? So the first argument is a float 100.006, and the second argument, which belongs to the second %f here, right, is 200.298. We are right justifying a minimum of 12 digits for the entire minimum of 12, right? If the number was longer than 12 digits, it would go ahead and print more than, 12 digits. But 12 digits per number or per argument, and then a precision of 2. But we're supplying a precision of 3, so it's going to round that number, round it up. Okay. So we see that it rounds up to 0.01 for the 006 or the 0.006 decimal, and then it rounds it to 30 for the 0.298. Okay, and then this is 12 right justified digits, and then there's a tab, and then there's 12 digits somewhere in here, right? And the tab, I think the tab might be set to 5 spaces. Okay, so to learn more about this is about as deep as I'm going to go into the printf function. But just know that you have these print conversions. I call them format specifiers. They behave a whole lot like Python formatted strings, where you put in a argument, you put in a holder spot for a particular argument, right? But you have to make sure that the first argument past the comma of the string that contains these print conversions, they correspond to the arguments themselves. So the first argument corresponds to the first %f here. The second argument corresponds to the second %f. All right, and so on and so forth. For your line returns, I wouldn't embed the line returns in the string, except for the most simple case. Put your line return on your format specifier and just leave your argument, because this is telling you what to do with the string. This is just the string here, right? All right, that's it for formatted output. And like I say, anything else that you needed to know about this topic, you could just return to the reference, which is the C programming language by Kernighan and Ritchie. And it's a great book, even if it is a bit old, right? It is still relevant today, and it's a good read too. All right, thank you very much for watching this video. I will catch you in the next one.